Okay, today we are learning about proportions. You are going to be able to create and solve proportions. You need to know what a proportion is. It is an equality of two ratios. What that means, it's setting two fractions equal to each other. When I say a ratio, it's like setting two fractions equal. You would say A is to B, and then you have this equal sign that you use with the word as, A is to B. Or no, I have to use different variables. C is to D. So I verbalize this by saying A is to B as C is to D. And they represent some kind of quantity, okay? It could be dogs, it could be cats, it could be people, it could be money, it could be scarves, it could be boots, it could be pants, it could be anything in the world. Yeah.
Why does it have to be variable?
Because it's different than that thing. It's a different amount. It's a different representation. So you're going to need to know what a proportion is, okay, and how to identify it. It's really setting two ratios equal to each other or two fractions equal to each other, and you're going to be asked to determine, do two ratios form a proportion? This is how you can tell. If you can multiply one fraction to get the other, they are proportion. If you can multiply one fraction to get the other fraction, it's a proportion. If they simplify down to the same reduced fraction, it's a proportion. So if they simplify down to the same reduced fraction, they're a proportion. That's fine and dandy. That's more 5th and 6th grade level work. This next way is what you use as 7th and 8th graders when you're looking to identify. That means you set their cross products equal to each other. If their cross products are equal, then they are a proportion. What do I mean by that? Cross product. What you do with the cross product, you multiply the diagonals. You think cross, diagonal. What you're going to do is multiply the diagonals. This is the only way I'm going to show you. Okay, I'm always going to show you cross product way because I need to make sure that you know how to set them up. You can do some of these mentally, you'll be able to do. But you need a strong foundation for setting up cross products to be ready for some of the higher, more rigorous proportions we're going to solve. So the first one, I want to know, given these two fractions, do they form a proportion? And how I identify that, there's 3 ways. I can say, do they simplify down to the same thing? 10 15ths can get to 2/3, yes. Can I multiply one to get to the other? 3 times 5, 2 times 5, yes. But the more important thing, now I wouldn't expect you to do cross products here, but I'm going to introduce it. Cross products, I would say, does 2 times 15 equal, and then multiply the other numbers, 3 times 10. 30 equals 30, yes, they are a proportion. If they're not, you say no. Yep.
I do something similar to that in elementary school.
Uh-huh.
I would multiply 2 by 15 and divide that by 3, and if it's 10, it's proportional.
Sure, that's the same idea. Yep. Okay, 1/9. You can usually tell right away with 1/9 that it is 9/81st. Okay, because you can see you multiply. But let's just set it up with a proportion or with the cross product. Does 1 times 81 equal 9 times 9? 81 equals 81. Yes. Okay. So we got 2 yeses. No problem. They will not always be yes.
In our assignment, I need to put yes or no.
Yeah, but I want you to show your work. So that kind of great question. He says, can I just put yes or no? I'm going to tell you that what I would do if you don't do the cross product method, you could say yes, but then you'd have to say something like 10 15 simplifies down to 2/3. You'd have to tell me how you know that, okay? All right, next. Solving proportions. This is the algebraic representation. You set their cross product equal to each other first. And then lastly, you'll solve. So set their cross product equal to each other and then solve. The first three a lot of kids can do mentally. I'm jumping right to proportions, or setting the cross product, I mean. Okay, I always use the side first that has a variable. I don't know why, something about me likes a variable on the left-hand side. I can't stand when it's on the right-hand side. It messes me up all the time. So I choose 8n first equals 3 times 48. 8n equals 144. Divide through by 8, n is 18. Now you could do that one really in your head, right? Because you see, hey, I can go 8 times 6 to get to 48. So 3 times 6 would be 18. You're really creating equivalent fractions, like when you're finding common denominators. So that's okay, but you can't always do it in your head. So you have to get this technique down. Next one, I'm just going to do the cross product method. Again, I choose the side that has the diagonal that has the variable, because I like my variable on the left. And 42, the next cross product, 42 times 40 times 2. 7x equals 84. X is 12. Next one, again, probably one you can do in your head. I'm just setting up the cross product to show you. I choose my variable first. 2x equals 8 times 5 is 40. Now I'm going to stop the actual multiplication showing because I'm assuming you got that now. X is 20. Okay, the next one is a little more difficult because I can't go, I usually always look at my smallest one. Can I somehow get to my biggest? It has to be through multiplying or dividing. So I can, so I'm just setting up the cross product. 24x equals 120. And then I'm just going 120 divided by 24 is 5. Okay, again, setting cross product equal. 12y equals 72. 6.
Can I use a calculator?
Yep, this whole unit you can use a calculator.
Oh, sweet.
28y equals 56. And y is 2. All right. So make sure that to keep teachers okay with using a calculator, you need to make sure that you're showing this minimal step. The step isn't that hard to do, and you're showing me that you know the math. You're just doing the tedious stuff with that tool, with the help of a calculator, and that's okay. That's okay that you adults use them all the time, but I care more about the setting the proper proportion up in cross product. All right, I want you to go through and set these up on the next page, solve them. I will call on names. All right, we have just went through solving proportions, given numerical statements. Now we're going to up it up to a real-life application, which involves word problems all the time, almost all the time. Anything as 7th graders that we deal with proportions, or any word problem that you get as a 7th grader, chances are it's a proportion in the making. So ask yourself, can I create a proportion? This is how we do it. We say object A is to object B as object A is to object B, okay? You're going to be given two things that you're relating to each other, and you're going to be given two different quantities. first thing I do is I create my proportion skeleton. And when I say create your skeleton, it means create your equal fraction bars. And then you just fill in the blanks. Okay? You will always be given a first relationship, which will be your first fraction in your proportion. Okay? You will always be given a first relationship, which will always be your first fraction in a proportion. Then you will be given one of the other object values, and you will need to solve for the missing one. Let's jump to an example. Now this example, there's a reason I chose this easier example. I chose it because you already are going to know the answer, which will help you be able to visualize more how to set it up. 2 baseballs cost $6. How much will 7 baseballs cost? So I have, don't tell me the answer, I'm going to set the proportion up. I have the relationship of dollars is to baseballs. Dollars you always want on top, just always. Anytime you see a dollar amount, make it on top. So now I'm making my skeleton. So it should be dollar is to baseball as dollar is to baseball. That's what we're going to do. 2 baseballs cost $6. The 2 baseballs goes on the bottom, the 2 goes with the baseball, and the 6 goes with the dollar. Okay, dollar is on top. As, how much will 7 baseballs cost? Is that going to be on top or bottom? Top is dollars. Is this 7 a dollar?
No.
The 7 is a baseball. Baseball needs to be on the bottom. Now I can solve. 2x is equal to 42. X is 21. Now granted, you could do that one in your head. I get that. Or another strategy would determine how much for 1 and times it by 7. Okay, that's the unit rate way, which is totally fine too. Next one. 4 CDs cost $54. How much for 3 CDs? I have $1 again. Dollar is to what? What's my other thing? CD. Dollar is to CD. Create my skeleton. And now I just line things up. I'm given my first relationship right here. 4 CDs cost $54. 4 is a CD. CD goes with CD. 54 is a dollar. Put it with the dollar. 3 CDs. Top or bottom? Bottom. Solve with cross product. 4x equals whatever 54 times 3 is.
162.
162. So x then would equal
4.5.
okay.
40.5.
Now we're talking about real life things. Imagine that you're going to a gas station to buy something. You're buying yourself a Mountain Dew or a water or a Sobe, whatever the heck you're buying yourself. Is the cashier going to say 40.5? The cashier is going to say $40.50, please. Money, keep it real. Money is 2 cents. Unless it's a whole number, then you can say 40 bucks. Yep.
What happens if we accidentally do that on our homework?
I want you to be very careful about it. So I'm going to trust that you're not going to do that. Okay? Because you're always, this is real life application, so you're always saying, okay, 40.5, what am I talking about? That's how much 3 CDs are going to cost. Wait. I got cents going on here, so it should be 50.
There's an easier way how to do that.
What do you mean?
If you take 4 and you divide it by 54,
54 divided by 4?
you go to 1350, and then you times that by 3, and then you'll get the answer.
Yep, so Emily's strategy there, she's finding that unit rate cost again. You can always go that route. Find how much for 1, and then multiply it by what you're looking for. Yep. But there's going to be times where it's not as easy to do that. 3 pans, cost $32. How many pans can you get for $100? Now, what's my relationship? What 2 things am I talking about? Dollars to pans. Dollars is to pans. create my proportion. 3 pants cost $32.